We're good? All right,
hot, yeah.
awesome. Mic is hot. So, show of hands, how many people attended DockerCon? All right, that's good. That means I actually am maybe showing new stuff. How many people heard or watched the live stream on the announcement of Docker 112? Got 1, 2, great. And how many people have tried it out? 1, 2, all right, perfect. Well, that means it's going to be a useful set of slides then to go through. So 112 is like the annual Docker raising of the bar. So last year we were at 1.6, and all these companies that were doing hot networking through containers had products, and they went to DockerCon, and then DockerCon announced networking included.
Right.
And this year at DockerCon, right, we had a lot of partners who lined up who were doing orchestration. And what do at the keynote? They again say, hey, orchestration included. So Docker's mantra a lot is batteries included.
Put all their friends out of business.
They like to raise the bar and say, hey, if you're going to value add, let's really value add, right? So batteries included but swappable. I think they're listening to their customers. Most of their customers in the first couple of years were developers. This has really been a developer-driven technology. But as developers actually start to produce things, right, these Docker containers and Docker images land in operations where they got to figure out how to actually turn them into something useful. So Docker 112 really is about making this more operational. So I only saw a couple hands for version 112. How many people had the privilege of working with beta code under Swarm, Docker Swarm? Oh, it's 1 or 2 hands. Was that fun or easy?
No.
No. It was batteries included plus a lot of elbow grease. Anybody here used Docker Compose prior? Okay, so more hands for that. That's definitely more the developer side. And so what you can really look at the first year of these ecosystem tools, so Docker Swarm, Docker Compose, Docker Machine, was that they were trying to prove out these additional functionalities without breaking the Docker engine. And 112 finally started to bake in a lot of those features directly into the Docker engine. So the very first thing up is Docker Swarm mode. So no longer do you have to install a separate binary or container running Docker Swarm. Now the technology has been embedded within the Docker engine. Now you don't have to use it, so it doesn't come turned on. It comes turned off, but if you want to use it, you start with a very simple command, Docker Swarm init, and you do that on your first engine, and all the hard work we used to do gets spun up magically in the background, and you get your first Docker manager. And if you want to add any additional nodes, why, it's as simple as spinning up another Docker host, and at the command line doing Docker Swarm join, and pointing it to the original Docker manager. And now I have another engine participating in a Docker cluster. And you can do that n number of times. And that's huge. I mean, this used to be something you'd have to custom kind of figure out. You'd have to make sure all the networking was in place. You'd have to spin up your own KV store in the back end. And now Docker's taking care of that. And the other concept to come out of this was services. So you can think of services as the new run for operations. So everybody here has done Docker run? See a lot of head nodding, great. So how would you like to have Docker run be more intelligent, like be able to persist the number of containers in an environment, right? And do health checking for you. Well, that's what Docker service does. It basically soups up the power of Docker run and allows you to create a scalable container service. So here we can see on the bottom line, I've used Docker service to create a 3-container service based on an image called frontend_image, tagged latest. And I'm publishing it globally to port 80 throughout my entire cluster. So this has big impacts. Now, I put out an image, I will let it land where Docker cluster smarts decides that it belongs, and it will publish its service port throughout the entire cluster to make it available to any node that you might hit within the cluster. And we'll talk a little bit more about how Docker Engine is doing that. So now, as I said, wouldn't you like it if Docker Run could persist the containers in case of node failure, right? Or scale things up for you. So once I create these services and they live out there and I suffer a node failure, say like that one with the 2 containers on it, what happens? Docker service now has embedded logic and says, man, they really wanted 3 copies of this running in the network. I better bring up those other 2 copies somewhere. And so boom, the desired state notices that I have a lack of 2 containers, and bang, it brings up those additional 2 containers to achieve the desired replica state. Now I know if you guys have been working with other orchestration managers, this has been embedded there for a while. Now it comes kind of batteries included for Docker. And so that's the concept of their new service level object. Any questions at this point? No? Good. So the other feature is scaling. So I won't call this, I hesitate in fact to call this auto scaling, as there is some manual processes involved. But much like the Docker Compose functionality that you had, where you could scale individual containers, just by saying, hey, scale this container up to X number of instances or down to this number of instances, Docker Service has that scale feature built in. So you say Docker Service scale this service equal to some number of nodes, and it will achieve that desired state. So it's not auto scaling, but it's certainly a kind of scaling. Your application does have to be smart enough to do kind of horizontal scaling of services, right? So it's not bringing up one more Redis engine to service all those. It's still 10 to 1 right now, right? So you have to have some internal mechanics to your application to know how to scale that back-end piece properly. The other nice thing is, how often do we have a container that we want to run on every node? Say like a CAdvisor container to help me do monitoring, or a Datadog container to collect metrics. So now as part of services, I can create a global service that will ensure that a particular kind of container is spun up on every node in my cluster, regardless of where that node exists. Right? So these are a way to create kind of global services in the vein of some type of health checking, monitoring, or antivirus. Yes?
So how do the global maintain state between each other?
That's still, again, up to the internal mechanics of the application itself. But they have now their own private network and can call every container by a label name or container name. So they have the ability to reach each other much easier than they did once upon a time. And we'll get into that here in just a sec on how they do that. Any other questions? Perfect. So I saw only a couple hands go up for Swarm. So I'm going to just add a little Swarm tutorial here. Has anybody ever configured a Docker engine outside of the default configuration? No. Okay, great. So the Docker engine has a concept of labeling. You can add metadata labels to an engine to basically give it some additional information that's not part of the vanilla configuration. And these may be labels like, region equal US East, or storage equal SSD, or QA, cluster equal QA. And Docker Swarm has the ability to scan all the participating nodes in the cluster for these labels and constrain the available targets down to just the ones meeting the label criteria. So I can say, hey, I want only things to come up where the storage is of SSD, right? So if I look here in this example, I have 2 nodes where they have a custom label saying that the storage is SSD. So the next time I deploy containers, when I add that constraint, storage equal SSD, it only has 2 valid targets. So it will only place those containers, no matter how much I scale it, onto those 2 valid targets, rather than treating the whole pool of Docker hosts as being valid targets. So this is a way you can start orchestrating more precisely where your containers might land in your container host cluster. So if we want to think about it now, right, I said that services are kind of the new run. And so services basically have a little more data that Docker's maintaining about these containers. It has a desired number of actual containers to be spun up, the version of the image that's associated, so services allow for rolling updates by simply calling different tags on your image. And again, kind of positional where it's actually living in the world of your Docker engine. So it's going to associate that I'm on node such and such. I don't know, they use random UUID, so you can never really quite tell what node you're on. And so you have all these individual services, right? If I want to get fully into the concept of compose files, where I have services describing a list of containers, how does operations deal with that? And so we come to the concept of a service stack. So the other top level object that Docker has introduced are stacks. And stacks are basically just a list of different container services and the number of containers that are required per service. And they are distributed in a distributed application bundle, otherwise known as a DOB file. And so, yeah, people just like acronyms. I've decided that. 3 letters or 4. And so here we go. We have our service, which defines the task of bringing up X number of these Redis containers based on that Redis image. And it's one service amongst the 3 services in the stack, right? And so now I can orchestrate directly to Docker without having to use compose in between with these DOB files. And so again, all that time that we've spent with these, segregated tools, the functionality has been brought back into the Docker engine itself. But of course, yes?
Is the compose format then obsolete for using this?
No, so they intend, so when you think Docker, they really love developers first and think of everybody second. So they want developers to continue to use the compose format to orchestrate locally. They then have a way to convert that file into they basically hash it into a DOB file for you.
I see. So in production, this is what you would.
Yeah, in production, you ship this around because the DOB file includes the compose file plus anything you need to build the subsequent containers that might be in the container file, or sorry, the compose file. So Docker started out, in a strong belief of the Unix philosophy, and also the concept of batteries included but swappable. So as I said, swarm mode does not come enabled. It's completely optional, and their intent is to keep full backwards compatibility. Now you can ask all the other orchestration engines how much they trust Docker to do that, and you'll see that most of them haven't quite moved to 1.12. They're all still vetting it out, mostly because they're concerned that some of these features might be getting in the way. But so far, I haven't seen it break anything in particular unless you were dependent on something existing that doesn't exist anymore. And I really can't think of a single thing in Engine that doesn't exist anymore. So I will say UCP broke, so something obviously got in the way. So let's get into the weeds of it, right? So that's kind of the high level, right? So we've added swarm mode to integrate our kind of virtual cluster of Docker hosts. We've added this concept of services running in production that is basically a series of containers that the service maintains state information for. And we've introduced the concept of stacks so that we can stack up all these services. What's happening under the covers? So last year, like I said, the big kind of announcement at DockerCon was we're going to include networking. Because the biggest complaint we get from all our developers and users is containers on different hosts can't talk to each other easily. I've got to go figure stuff out. Well, it took about 6 months after that announcement, but it works pretty darn well, and they've made it work even easier. So in the spring of this year, with the advent of version 1.9, 1.10, and 1.11, several things happened. Thing one was a DNS service was embedded into the Docker engine so that containers could call each other regardless of where they resided by name, right? Thing two is they set up a internal capability to use a KB store to set up an overlay network without you having to figure that out. And 112 takes this a step further. It's embedded that KB store and created mesh networking across the different nodes that participate in the cluster now. So this routing mesh basically does a couple different things. One, once I bring up my service in my Swarm cluster and it propagates all my different containers, like I said, you can publish a kind of global port for that service regardless of what node you might hit. And the mesh network is responsible for directing traffic to a container somewhere in that cluster. So here we go. I have my manager at the top. I've got my workers down there. The applications are distributed amongst the workers. And I have basically designated a port service of, well, the command doesn't say it, but the picture does, port 8080. And so from the outside, I can hit any IP address participating in the Docker network, call for port 8080, and it will direct it to one of those front-end containers to provide whatever service it provides. Additionally, it's load balanced. So let's say you hit node 3, I don't really see anything, so there's a built-in load balancer in the mesh network that says, hey, where does this exist among the mesh? Oh, there's some on node 2, let's do the traffic there, and the next one I get might go to node 1, so it's a round-robin standard kind of load balancing. And you say, well, is this secure? So that's the other thing, another big complaint. How many of you had to go through and do a hand-spun self-signed certificate? Yeah, only one of you suffered. I love it. Inside the Docker training courses.
Well, I suffered enough for all of us.
It's true. Right? In the Docker training courses, they have a module that take you through it. It's an hour-long module for people to roll out one cert, and that's with the directions in front of them.
Yeah.
Instead, Docker said, why should you be bothered to do that? And they rolled cryptography into their binary, right? So they are encrypting the connection between hosts. So all your private networking is encrypted on the private network, and there is no longer a concept of insecure mode if you use the Docker Swarm mode. The other thing that was a complaint was, or not a complaint, but a benefit of some of the other orchestration systems was, how do I do health checks? Right? I can no longer use my system level tools that I might have used once upon a time, and if I do something with my router, I'm not penetrating all the way back to the container because I keep hitting the front end connection. So now, thanks to some improvements to the Docker file, you can programmatically set up a health check. Say, set up health check in the Docker file, define how often the check occurs, how often it can get a timeout, and how many times it'll retry that health check before it declares the service to be unhealthy. Right? So again, they're slowly pushing the boundaries and elevating the bar to what others must provide, because they're starting to do some of this now just natively. Additional things they've added to 112. Last year they kind of introduced the concept of doing these plugins. They were kind of esoterically documented. You hope that whoever was writing the plugin provided really good instructions to tell you how to use the plugin. Right? Oh, this is how you install it. I have to git clone this library down, spin up another container, cross my fingers, and turn around 3 times, and hopefully it's going to go. Now they've kind of made it easier for somebody who doesn't really know anything about that plugin, doesn't want to do the research, to just do a plugin install and to enable it or disable it. This is actually fairly useful in terms of large-scale networking and storage. I think are the primary places right now. But additionally, they are starting to introduce authentication and authorization plugins. So there's a heavy amount of development there. Plugins have different kinds of permissions. So we can see it requests the following privileges. Can I access the networking on the host? Can I mount path on the host? And so it kind of lets you know what this plugin is going to do to you before you suck it into the system. And you obviously, it's a opt-in as opposed to an opt-out.
Where do you get the plugin?
You can find the list today in their documentation. I think what they sold at DockerCon was the store.dockercon, so it's like an app store, so I'm thinking that's where they're all going to come from at some point. They haven't fully described the process yet because they're in beta. I don't know. Chris, you heard anything back there like a Docker captain?
I'm sorry, about the
Plugins, how would you find out more about them? Do you think they're going to sell them in the store? That's just my thinking, or still in the docs?
TBD.
TBD. There you go. So let's get under the covers even deeper. So again, this is the swarm topology. So I have this number of nodes. A lot of people want to do hybrid clouds and multi-cloud clouds. So far, they've demonstrated this working with cheap demonstrations. So I don't know how good it is really between clouds yet, but certainly within a single data center, this works pretty good. You'll notice here that the topology requires that I have managers to manage all these worker nodes. Generally speaking, right, we are doing a quorum style cluster, so I want an odd number of nodes, right? So 3, 5, 7. You have no availability safety net if you're doing one, obviously. So generally speaking, you want to at least dedicate 3 nodes to serving at least part of their time as managers. So what does that look like under the covers? So the workers have their own gossip network to kind of handle the little day-to-day traffic between nodes, like handing off connectivity. But the, if you will, the service discovery plane is being managed by the managers. And so you can see here that the managers have an internally distributed state store. Basically, this is a KV store that's in memory and uses a RAF consensus group. And it communicates all this information down to the worker nodes via gRPC, which I found out means Google RPC. Didn't really know that. And so what does this RAF consensus group look like? It's strongly consistent, so it holds the desired state. It's simple to operate because it's transparent to you, the end user. And it's blazing fast because it's pretty much all in memory. Think of any in-memory cache system you've already used. That's about the speed. Obviously, as you get to multi-cloud, you really have latency issues because of the network. And again, Docker's doing everything encrypted, so at least as secure as TLS is going to be. I don't know. I heard somebody tell me what the actual underpinnings of the KV store was. Chris, do you remember what the underpinnings were?
I don't. I think it's, I don't want to be misquoted, so.
Okay. You see the video camera is on. He doesn't want to be misquoted. I understand. Anyways, additionally, like I said, the workers, right, participate in the gossip network themselves. So they're always talking to each other about what containers are running there, right? They have to communicate networking information to each other. They also, talk about load balancing, traffic volumes, and peer-to-peer between the workers. And of course, they have to do key rotation because, we would want to do TLS, but we also want to do it better than hand-spun. We want to be rotating that key on a very, very regular basis, so that's very hard to hack. So I think in the early days when Chris and I and Jerry were kind of designing these things, we talked about the big change in networking being that east-west traffic was going to increase with these kinds of designs, and this is kind of that traffic being generated. None of this is going out to the internet. It's all happening in data center. And I would also say if they're starting to collect metrics, you can see kind of some future capabilities where they want to do some true auto-scaling or load balancing, right? Dynamically, they could start moving things around based on some of the metrics they're now collecting. So what does the node look like? You can see at the very base is the worker node. So it has the worker agent, which connects to the dispatch to check on assigned tasks and executes those tasks. So any join node that's a worker, that's all it's running in the engine, so it's a fairly light load. The manager nodes do a little more. They have the API that you can send requests to that are shared and distributed. They have the orchestration bits turned on so that they can understand the DOB files and do the service discovery. They also manage the cluster level allocation of IP addresses. Right? So we don't want to have IPAM just on a node, we need it globally. They also assign nodes tasks, so they're the ones scheduling where containers get brought up in the field of workers. And finally, the dispatcher is what actually does a lot of that communication to the endpoints. Inside the load balancer within the mesh, basically every service is assigned a VIP, and in this case, VIP stands for virtual IP, not very important person, and that service binds it to inside the DNS, and then every container gets attached typically to its own private network that's behind that VIP. So as we see the networking model in action, this is Docker's networking model. This is called the CNM, or Container Network Model. This is distinctly different than the Kubernetes approach, which is the CNI, the Container Network Interface Model. And the two really aren't super compatible today. So this is a choice that you're going to end up making. Part of that choice is that every container has a virtual interface that connects into a network of some sort, rather than sharing network namespaces between services. Additionally, the DNS, like I said, is built in at the engine level, so every engine is capable. Yes?
Yeah, so currently whenever we have the multiple app servers, right, so there used to be F5 and other companies who used to specifically give the load balancer, which is routes. In this case, it comes from the out of the box on the Docker, or is there any product supposed to be?
So you will still need the F5 for front-end load balancing, meaning traffic ingressing from the internet and dealing it back. But after it gets to the back end, Docker now has the internal mechanism to provide the reverse or back-end service proxy.
Okay.
So essentially, Docker has the ability to assign a label. So let's say I don't know what this container is called, but I know the service is called demo. If I call for demo on this port, Docker will figure out how to route you to the nearest container running that service.
Okay. And if it goes down, then it will automatically route the traffic to the
next active node, and it'll try to bring the containers back up, as long as you have the space. Yeah. So yeah, all that back end work. So once upon a time when we had to hand roll this, you had to have the swarm container to do the communication piece, so basically the scheduling agent. You had to hand roll your own KV store. You typically chose etcd or console or Zookeeper, whatever you were familiar with. And you had to set up an HA proxy service on every host to handle what you're describing. And lastly, you needed some type of service discovery mechanism. Our favorite happened to be a sidecar with DNS mask and registrator, so that when containers created, they could register themselves with a proxy service. So all that had to be done just to get what this is doing by saying swarm init. So I'll tell you what, man, they made the work a lot easier and more useful for all of us. I don't know. I'm glad my job is more than just installing Docker. I'd be out of the job. So this is the way the ingress load balancer works. As I said, that front-end load balancer, right? The F5 is still there. If you're in the cloud, this could be an ELB or the Google routing engine up front, whatever it might be, right? It's going to handle the domain and public IP for you. It will then shoot the traffic back to a private IP address to some service port. And again, each service will get a probably distinct port. It will hit any node within the cluster, and the cluster will be responsible for routing that traffic to, again, a container. Today, almost all the container schedulers have very simple load balancing methods. They basically do a round robin. So there's not a lot of complexity just yet. In fact, I don't even know if they handle sessioning. Haven't tried. This is what the end-to-end encryption kind of looks like. So essentially, the node managers have the certificate authority distributed amongst themselves, so they maintain the CA. They do mutual encryption on TLS and mutual authentication, and then they issue those certificates on a rotating basis to the workers and to each other. So again, I forget the frequency on this. They kind of mentioned it very, very briefly during one of the keynotes, but it's very regularly rotated out. So the keys have a distinct end of life. You're kind of seeing this architecture in general on large scale internet projects. So Facebook and a bunch of others joined to go to freeSSL.org to provide a publicly available free CA that issues 90-day certs. And so,
Oh, it's seconds.
no, it's 90-day.
No, for the rotation.
Yeah, it's a very low, I don't know how much overhead it's impacting, but it's a pretty low window. I would say if it's longer than 2 weeks, I would be probably very surprised. But probably seconds might be a little heavy on the traffic between the nodes. Yeah, that's something where you have to open a ticket with Michael Crosby and say, hey, how the heck are you doing this? or Madhu. So where can you learn more? So you can see this is the DockerCon deck. So I'm going to pop up the actual place that you can learn. We will be publishing a link to this repository at the end of tonight, right?
Mm-hmm.
Yeah. Let's see if I can find it here. Yeah, here we go. That one. So this is the Docker Meetup content. You can actually check out the Docker speeches that were at the at DockerCon itself if you want to see that, as well as different articles covering this topic. That's basically what's new rolled into 112. It is a, I don't want to call it a quantum leap forward, but it's a heck of a big leap forward from where 1.6 was, certainly, where we walked in last year. And even just in the last 3 months, it's a huge change that a lot of organizations are still ingesting. I don't know, anybody running 112? Anybody running 112 in production? I know most of you hadn't even touched it, so I just thought I'd throw it out there. Okay. Any questions before we pray to the demo gods and try some demos? No questions. We got a quiet group tonight. Too much pizza. Yes?
What about NoSQL running in swarms?
What about no people running on it?
Like a MongoDB or something like that?
Sure.
It's been tested well?
Oh, yeah. Mongo actually has an official repository that they work with Docker to optimize for container running. I think the probably biggest thing that you want to get, how large are we talking on the back end size for the shard? Gigs, terabytes, or petabytes?
Terabytes.
Terabytes. So usually when you get to that level, you really want to work out the scaled storage. And we have different companies trying to get into that space for containers specifically, like a Portworx, which do real-time replication. And then you have the traditional approaches like cluster, NFS, etc. So I think it's just working out the storage, but Docker has made it really easy to convey the mounting. So as long as you figure out how to share the storage everywhere, Docker makes it real easy to mount.
Oh.
Yeah. Any other questions? No? All right, I'm going to say my little prayers out there. I will say I kind of rushed this together in the car on the way in, so we'll see. Luckily, it was made by more smart people than me. Yes, I know that was very bad grammar. All right. Is that viewable? Yeah? Sure. All right, I'll take it. So let's get some real world examples going. I'll work through the actual first lab. So this first lab runs either on your machine. So if you happen to have a virtual box set up, this will run from your machine. Otherwise, you can configure it to run in any of the public clouds. It's using Docker Machine to help you set up nodes. I have already pre-prepped one script because it takes a little bit of time to do this. So we will kind of go back up here. So you can see that I ran my first script, which all it does is it runs Docker Machine to create nodes. So let's see if I can get to the very top of this. Ooh. So there we go. I did provision my nodes. We're using DigitalOcean because we teach in DigitalOcean, so I happen to have a really easy account with lots of with a very high limit of nodes. And so the setup here tonight is essentially 3 managers and 3 worker nodes. Docker Machine plus the script go out there. They create a host based on any settings you put out there. I'm doing very small hosts for our demonstration purposes. It then sets up a secure communication channel between you and it. That's all Docker Machine mechanics. After creating all the SSH keys, it then spins up Docker using one of Docker's scripts. So in this case, we're using the get.docker.conf script, which installs the stable version of the open source version of Docker. Once it does that, it sets up all 3 nodes and then basically just lists all the state. So right now I have 6 machines. All 6 machines essentially are running Docker. And that's it. There's nothing else on them. We'll take one quick look at the script so that I can see if I need to adjust anything, because I don't remember. Let's see here. So this is provision 1, any special variables. And this is probably the special variables Josh is going to need. So, again, kind of rocking back through it, I'm creating managers and nodes, and all it's doing is running this get.docker script here to install the Docker engine on these nodes. So next up, we're actually going to initiate the swarm mode, right, and get the manager set up and the machines set up. So first part will be to set up the initial manager, that first one to initialize the cluster. And then we need to capture the token, because the token is how we kind of communicate where to find everything. After that, the additional managers are set up, and finally the workers are set up. So this should be a fairly automated process. Chris is always fond of infrastructure as code, and this is kind of where you would start with infrastructure as code, and that is programmatically deploying infrastructure and configuring it, right? So that you don't have to hand spin them. It's not about maintaining an AMI. It's hopefully version controlled, right? So all these scripts should be inside GitHub or whatever your favorite SCM is, and anybody should be able to decipher them and run them. Whatever available tools. If you'd like to take it to the next level, right, the extra sexy level, you basically use tools like Terraform. You put those in containers and you add your scripts into the containers and use containers to deploy infrastructure into other containers. That's kind of the fun way to do it. And if you really want to go to that final level, you get your CI/CD server to look for code commits, right, and to use those code commits to trigger jobs. That will then spin up whole new environments for you. So that's kind of that's luckily why I still have a job, because we're out there trying to convert people to that. Yeah, I'm talking you off because I am just waiting for this. Did I lose my internet? Dang it. See, this is why you pray to the gods, because otherwise you get timeout errors. Let's find out. Oh, I still have internet. Man. Find out if Google comes up. It's not good internet. I forget the gentleman's name who helped me out with the mic, but
Yeah,
mic guy?
He's checking on it right now.
Oh, perfect. Alright, well, there's the one big problem with infrastructure as code is it does need a functional connection to the stuff you want to program, right? Any other questions we can answer? We're kind of waiting for the internet gods to be kind. No? Come on, Chris, throw me a softball. You can do it. Gotta sound smart, right, at the end of the day?
How about IP version 6?
IP version 6, are you asking if it's supported? Yes, it's supported. There is one pretty major bug in it at the moment.
Looks like it's logged in.
Yeah, it is logged in, so. I just can't, if you can bring up Google, I should be pretty good.
Okay.
I just been trying to bring up Google right there to try and find out. Yeah, right now, so we actually work with a pretty big internet firm to do consulting work with, and they use IPv6 on the container level. So it's there. There are a lot of big shops using it. Probably the only thing they're running into is a particular kind of frame. For whatever reason, the way the kernel is dealing with it, it truncates the frame. So that one kind of frame is right now being affected, and they're still exploring it. I would just say it's like a lot of IPv6, it's a small number of shops using it, so you know the improvements take a little time. Softball? I'm thinking of softball. Yeah, I'm usually a kinetic speaker, so what that means is I usually walk around a lot more. Unfortunately, my clicker fails to function with slideware distributed via website. So I was stuck behind there. I'm not much of a stuck behind guy. Oh, no, that's still Containers 101. Yes, I still read 101 articles. I like to know what people's perspectives are. Yes?
What are your thoughts on Docker Cloud?
On Docker Cloud, if you are a small development shop, I think it's a neat thing because it's a no-ops approach, right? Essentially, you use it to manage your Docker hosts in any public cloud that you like, and it enforces a good workflow. So I kind of like it. They paid a pretty penny for it. It was originally a company called Tudum, but it's a real slick interface, and it works with pretty much every major cloud provider I can think of. Chris?
Yeah, it's good.
Yeah, and it's got tight integration to all the Docker pieces. So I mean, if you really buy into Docker, it's a great solution. And it's not because I'm a Docker partner. I mean, I'm not trying to toot the horn, but yeah, small shop, it's a great solution. Any other questions? Yeah, you're just waiting for the internet gods. I know. Any more pizza back there?
Some more pizza. More pizzas.
No more pizzas?
We could order more pizza if we had an internet.
Aha! Ta-da!
I just logged off and logged back in.
See, you're the magic man. That's all it was.
Yeah.
Oh, was that you,
Start
Jerry?
it.
I heard you back there.
Nope, it wasn't working.
You waved the magic wand, right?
Yeah.
Getting castigated.
So there we go. The automation, the beauty of automation is at work. These are just straight out shell scripts. Again, these will be available in the repository that we distribute out. So you're more than welcome to, make them your own. So there we go. You can see that the joining is real quick, right? These are all basically sitting in the San Francisco data center. So that's roughly one local-ish data center. They're not going into another availability region, all the same availability region. You can see that I have 2 other managers up and reachable with 1 elected master and then 3 worker nodes ready to go. So next up, here is the actual lab itself. And let's get rid of that guy. So now that we have our huge swarm cluster all set up and ready to go, and I said this is basically taking apart those scripts a little bit. The next thing to do is to set up one of these services. So first thing we'll do is check out and make sure that this is functioning. So same old command, let's see. There we go, those are my 6 nodes up and available. I will close this out because I think I'm done with it for right now. There we are. And next up, we actually have to create our service. So here we go. This is the nice thing about Docker Machine. I can manage an entire cluster from a single box. So for those who've never used Docker Machine, this is basically their Docker's solution to managing Docker engines. So the Docker Machine binary with the subfunction to access the SSH connectivity. I'm telling it which manager I want to get. So these are all the labeled names. And I pop in the labeled name and I say, hey, run this as an SSH command, Docker service create, publish to port 8080 globally, and make this a engine export. So there we go. If I want to take a quick look, so now I have absolutely no clue where this service has come up, right? I just know that I have a single container running Nginx somewhere. So I will just pick node 1 of my worker nodes, because again, just a wild guess. And I'm going to depend on that mesh networking to take me to the right place. And there we are. No real delay. Maybe it was running on that node, maybe it wasn't. I really have no clue. I had a 1 in 6 shot, so I'm either very lucky or Docker's routing is working pretty well. Next up, after we look at the service, right, we want to be able to kind of inspect our service. So we'll go ahead and take another look at the JSON arrays that Docker loves so much. I think I have JQ installed here. So there we go. This is where a smaller screen helps. So you can see my service ID, an index number, when I created it. I mean, if you've done a lot of Docker inspects, this should feel eerily familiar. My service name, which is called web, what it's running, so it's Nginx latest. If I were to really use services the way you should be using services, I would not be using latest. I'd be using some version number so I could do a rolling update, because right now latest is always latest. The restart policy, condition any, so always in any way you can restart it. There's no run of holdback. My virtual IP mode, so it's going to have a service virtual IP that all the addresses kind of listen for. The publish port I've done, which is port 80, the service port, which is the target port, so what the container is listening on is right there. And again, kind of just repeats the information based on where it's distributing it. If I want to look, that's the internal VIP, so 10.255.0.9, and this is a /16 network, meaning it's a class B size-ish cut up of the class A address scheme there. I believe that's a /16, right, Chris? You're a little more fluent in cider than I am.
It's been a while.
Only slightly, it would seem. So, what happens if I need more of these, right? That one little Nginx server is getting pounded because I only use 1 GB nodes, right? I have 6 nodes. Why don't we scale this guy up? So to scale it up, kind of again, we're reviewing what we're doing here. We're borrowing Docker machine. We're using its SSH function. We're calling our leader again, and we're just saying Docker service scale. I say what service I want to scale, in this case the web service, and I want it to get 15 containers from my one. And it goes and works its magic, scale to 15. So if I go back and just do my ls, we should see the desired state.
Drop scale.
Gotta get rid of scale, yeah. So there you go, I have 9 of 15 up. It's still bringing up other replicas. So usually some of the delay is if it hasn't pre-downloaded the image that it needs to bring up, then you spend some time downloading the images to the target nodes.
How many machines are you running?
As I said, I have 6 total machines. I don't know if the demo I set up is targeting all 6 or just the 3 worker nodes, because I didn't really set up any particular restrictions myself. This is kind of a poor example, merely because you really don't know, right? I mean, I could be lying right there that I have what I say I have, which is 6 nodes really servicing this. I'll use another IP just to prove that I can get to it from any IP, but I think it'd be more useful if I could see what container was serving me.
Yeah.
And so I will do that next here, but that's the simple lab. You can run this at home with all those scripts. And again, it'll run on VirtualBox, so it'll run locally, or it'll run in any major cloud provider. Let's do a more complicated lab that actually makes it feel like I've got more than one container rolling. So let's see here. Yes. Oh, here. We will do this one. I do like to see where it's running. So these are all the cool little bits. So those are all the replicas that got put up. So you can see the service name, web 1, 2, 3, all the way to 15. How long it's been running. So only one's been running since I started this guy. Don't know. They don't show in the service PS where it's running. So they could be running on node 1 or node 3 or one of the managers for all I know.
All of the above.
Or all of the above, yeah. Additionally, we can drain nodes. This is to remove services from a particular node. So I'm going to say remove it from worker 1. And so it should remove, oh no, that does say it, there. The node column, see? I'm looking.
Oh.
So I had 1, 2, 3 working on node 1.
So how many services do you think will be running now?
Should still be 15, should just drain out node 1. So we'll grep worker 1. And I have one worker 1, so there's one place that I caught that it hadn't drained away yet. Well, I'm just draining it, never mind. Let's go back up. There. Oh, I still got it. Oh, shutting down. There we go. And you'll see kind of the substitute ones where they brought it back up. So it looks like they brought one up on node 15 or node 2. They brought one up on node 3 or node 3, and they brought one up on manager 1. So it looks like it's using all 6 nodes to act as my pool. I didn't restrict it anything with any constraints, but that's, small demo. I only got 6 gigs of memory to roll around right now. Additionally, we can look again to see how everything is going, although I think the draining is complete, to be honest. So active up, still got in the drain state. What happens if I start killing nodes? So one, we will scale this guy back down. We only need 10. I got less nodes available. So we'll scale away. See until they scale down fully. Come on. I see a lot of shutdowns in the process, so I wonder which ones I'll be left with.
By default, it's still spread.
Yeah. In fact, they don't even mention bin packing anymore. You really have to dig for it. So Docker has two strategies for distributing containers. Spread strategy says to move containers and distribute them evenly across all available nodes that meet the constraints. And bin packing would say pack them all as deep as you can until you exhaust resources on a single node before moving on. Well, eventually this thing will finish shutting things down. Although it says it was already shut down, so maybe I'm just doing some tracking. The real key now is to start bringing some stuff up. So, boom, 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 boom. So now the active one. So if we take a look with the pretty print. So we can see I have worker 1, it's now in availability mode is equal to active, it's ready, what it's running, again it's got a little less than a gig of memory, and all the available network options it has at its disposal, and the version of engine, and in this case who the service provider is, DigitalOcean. Finally, I'm going to start killing nodes. So this guy will eject one of my managers. Alright. So manager 1, swarm leave. Let's get rid of this manager. Boom. The node has left swarm.
Elvis has left the building.
And we will check to verify that on node 2. Yes, he has. So manager 2. We are now down to an unreachable node because he was ejected. Our new leader is elected manager number 3, and worker 2 is reachable. Again, we generally like odd numbers for our quorums, right? So we generally would want to try to bring back that other node, or if we had a higher manager count, bring it down a little bit. Even numbers can lead to tricky situations if we have network issues. Finally, how do you clean up? You do this guy. This removes all our services. Just to verify. Oh, I don't even have web to call anymore, would be my guess. Yeah, what are you talking about? Go backwards, PS Web, maybe? Oh, PS Web. Exit status 1. This guy is gone. And like any good infrastructure as code architecture, taking it down should be just as easy as bringing it up. So that will go out and kill and clean up all my instances, saving me dollars per hour. Yay! So let's get a little bit bigger environment going. Yeah?
Does that remove the images too from the nodes?
Yep. It completely destroys it obliterates the nodes.
Yeah, that's killing off the nodes, not going into the nodes and removing the images of the.
It's actually killing them.
Yeah,
Yep.
that's removing. So that's Docker machine removing the nodes.
So that Docker machine's not going to run on those nodes.
They don't exist anymore. They will be blinked out of existence. It's like wiping out the instance or terminating the instance in
So where's
AWS.
Docker machine running now?
It's on my machine. It's always been on my laptop. Like I said, you can run everything from a single laptop if you do it right. Or if it were Automagic, I could probably talk to a Slack agent on my phone and tell it to do stuff. I'm not that cool though. We're gonna source out a little environment variable so I can do my work, and we are going to create a new swarm cloud. I'm doing this because this is what everything else was done. So I have 3 managers and 5 workers this time. So this may take a wee bit longer to come up. So what we're going to do with this one, ooh, I didn't give it the full, sorry, I didn't give it the full Monty.
You have to tell it a different provider.
Yeah, I have to go to my notes, which is why I created them all, and copy this nice command line. See? I knew I would forget And that's why I copied it all down so that I could just cut, copy, and paste. Oops, am I on the right? Ah, well, can't spell, can I? Let's get over there. It's not clowned. Yeah. Alright. Or is it? I don't know. At this time of night, it might just be. So again, I mean, you know, this is making a lot of what was hard jobs easy. Being able to call any container by its name internally is huge. Being able to set up Swarm in under a minute is bigger. And then setting up all that proxy service stuff and figuring that all out, that cost him a day of his life.
23 and a half hours.
23 and a half hours gone, wiped out. And it's all in there kind of transparent to you. I mean, it's hard to know how much that can help things. Obviously, it depends on where you are in the development of microservice architectures and other things to kind of leverage all this stuff. But if you're going down that road, you know, you asked how Docker Cloud does it. Docker Cloud just wraps a bunch of GUIs around these kinds of scripts, right? So it turns somebody with 0 ops skills into the master operator of every cloud imaginable, as long as you have a credit card. Right? This process takes a little bit. So, if there are any other questions, I'm happy to go through the rest of this demo. This will also be up on the web with some modification. Yes?
You've had experience with Docker for a while. From the perspective of how heavy is Docker getting for, let's say, lightly machines?
It still runs on Raspberry Pi, so that's pretty light, and Nooks.
Yeah, that is.
It's a Golang binary, so it's compiled at the machine language, unlike a lot of other things that we're used to using that are in the web world. It's still, in terms of tightness of binary, it's still underneath 100 megs. I know that sounds like a lot, especially from the command line world, but it's not that bad for all the services it gives you. They have begun to, under the covers, decouple things so that you don't necessarily have to have all of this. So for instance, Containerd is another project they run, which actually does the container management. So this is becoming kind of an orchestrator for all these different services. So pretty good. I haven't, you know, they speed test it themselves all the time, and so I'll take it a grain with salt on how much a company speed testing its own product can do. But they can spin up 1,000 containers in under 5 minutes. And as far as, you know, resource consumption, everything you're seeing is running on a 1 gig, 1 vCPU cloud instance with low priority. So this is not exactly, you know, these are not the most robust things in the world.
My standard DigitalOcean machine is half a gig with a bunch of swap because I'm cheap.
Sure. Well, it's all SSD, right? It's supposed to be cheap SSD that you're swapping to, so that shouldn't be too bad. You know, it's honestly the bigger impact isn't Docker itself, because after you get Docker installed and running, it's just in the background managing kernel processes for you. So it's a slightly better manager in terms of isolating it in containers, but it's the kernel that's doing everything. This is just the namespace. It's just a control group. If you think about it, the modern Linux operating system, everything you do is in a master control group. So from that perspective, you're in one big container anyways, right? Docker is just kind of helping you out by doing the software-defined networking for you, because that's a pain in the butt to do on your own. And it's doing the HA proxy. You'd have to put something out there. HA proxy isn't a free service, and otherwise it's just the kernel. So I mean, I know there's some arguments on you know, kind of out there in the ecosystem of, is Docker doing too much, right? Is the binary itself getting a little too bloated? Sure. I mean, I think if you're looking for it to just do containers, aka bring them up and take them down, yeah, it's too big. Does way too much. But you have a lot of good alternatives for that. I mean, Rocket's out there, Containerd's out there, hell, LXC's still in the kernel. So, that answer your question?
Oh yeah, thanks.
Yeah.
So how much each process used to take, like if you have a 1 gig RAM right on the cloud and you have 10 different containers, right? And each container will have their own processor.
So are you asking how much overhead the containerization process takes, or how much each process takes?
It's like, yeah, I mean, you have a process and within that you deploy the apps, right? So, so how much overhead each and every container takes to manage?
So if I just measure CPU and memory, it's pretty fractional. It's less than a single percent. There are debates on how much. From IBM, who did their own test rigging, it was 0.1%, or in that neighborhood. If you ask somebody else doing something else, it might be more, but it's usually never more than 1%. The bigger bottlenecks tend to be I/O and tend to be network. Right? Those are the two things that kind of bottleneck things more. Also, badly written code. If you have a piece of code outside of a container that has a memory leak or a runaway process, the container isn't going to make that much better for you. It will just reach the endpoint faster if you put the constraints in.
And also the modules, if you know that these two modules are going to communicate, put it in a single container rather than putting into the different multiple containers which will
indirectly add some additional networking and overhead issues. Sure, but I would say overall it's not huge. I wouldn't call it a huge amount of overhead. So the process will take what it takes. You have a question, sir?
Yeah. In terms of orchestration capability,
sure.
For where Docker is now, based on what's going on, how does that relate capability-wise to something like Mesosphere? Just for container orchestration, not the larger.
Sure, not the larger ecosystem.
Is it parity? Are we getting close?
We're getting closer to parity. I would say Mesos is a little better in terms of the load balancing and the auto scaling. They've been doing it a little longer. But it's still rather simple in terms of auto scaling and such. But I would say if you had less than 100 nodes as your hosts and less than a couple thousand containers, I'm not sure that you are gaining a large amount by putting in the Mesosphere control plane if you only need management of containers. Now, if you need more stuff, Kubernetes does Mesosphere does a lot. So I don't want to discount Mesosphere. It's a very good product.
Yeah, if you're scheduling other long-running processes, right?
Yeah.
We're starting to have these conversations.
A Cassandra cluster you need spun up real quick, right, to have the universe that they maintain. So I mean, it's a very good product, but man, it's hard justification to add complexity unnecessarily for somebody like me. I have to ask why, and honestly, in my opinion, it doesn't really matter at the end of the day, because if you're doing it right, you've created an automated process that, like I said, that you are not spending time doing provisioning and doing kind of manual work. You're spending more time performance tuning, monitoring, and trying to get more out of your networks, because everything else in the provisioning pipeline has been automated away. That's the end. That's really the end desire. That's how you get a site reliability engineer at Google managing 12,000 machines by himself, right? It doesn't happen any other way. Because if he had to go through and change hard drives or set up VMs, it'd just be an endless chain of emails you have to respond to, right?
But for him to manage 12,000 machines, he needs a lot of these controls that the older products have, like the Kubernetes namespaces or the Mesosphere groups.
Sure.
That you take that single pool of servers and divvy it up by department, hook it with billing, chargeback, and all that. Be the platform.
Oh yeah. And also, I'll say this straight out right now: none, flat out, unless you go into a cloud and buy their system, none of the vanilla open source products is a complete product yet in terms of doing what you're describing. They're on their way there, and it's definitely designated. But chargeback systems, I don't find that in open source Kubernetes yet. They do in GKE.
Oh right, but they give you the model.
Yeah. Oh, absolutely.
For storing everything you need to store, so that you can hook in your load balancers outside.
Oh yeah.
Systems in your cluster storage volume.
But I will get back to how many people here, raise of hands, are running even 1,000 servers. Yeah, right. I would say the average use case is a couple hundred nodes is a pretty big place for a lot of people, right? And so for that, there's all learning curves. Probably one of the more popular configuration management softwares out there is Ansible. Doesn't do anything more or less than Puppet, Chef, and Salt. What it has is a really shallow learning curve, so people can start using it right away. This is a really shallow learning curve at the end of the day. But yeah, I think there's subtleties. I think as the things mature, I think it will have a better, Kubernetes, for instance, will have a much better scheduler if they really meet what they put out there. And if you need that complexity, it's the way to go. But you got to start somewhere. Oh, right. Did we get all our hosts? No, see, this is just a slow process. That's what you get for 1 gig VMs. Yes, sir.
One thing I still missing is it still runs with the root. Can I run without?
You cannot run the service, so the daemon, outside of root, but what you can do now is apply namespace remapping so that the container's root is not mapped to system root.
Yeah, that's. Do you have any more information on that?
It's fully documented on Docker's website. Look up namespace engine configuration, and it'll tell you step by step how to enable namespaces. I will say it's only been in there one version, so there are some issues of getting that mapping right that they're still working through, but the functionality is there. The other thing that people underuse, to be very honest, is containers should never be run as the root user. You should use the user directive at all times to use some low-level users inside the container itself, because if you don't include sudo and there's no password, anybody getting in a container has a very hard time compromising the container security, because it's just not there. The other extreme is, you get to some of these shops that kind of started in container land. Their container images are one binary in size. They don't have anything but a Golang binary or a JVM plus a Java jar, and they roll up on a kernel. And that's, what's there to do with it, right? So there are a lot of ways that you can kind of tighten it down more than it is, and the namespace mapping, I think, addresses your specific concern probably best. Any other questions? No, we're just waiting around for the demo, gods. It is, I will give everybody a time check, it is 8:45, or 7:45. So I don't know if anybody has to skedaddle because of it. Anybody have any stories to share? It's been a little while since this group has met. Christopher, you got stories.
Does anybody, that you asked if folks are running production?
Yeah, who's running in production any kind of containers? Hey, want to talk about it?
Not really.
Fair answer.
I was really Kubernetes just across France and US.
Nice.
For small services. But like, we're starting a new project. We're gonna go in production and will be more than to talk about. While I was installing Kubernetes, I played with cluster FS. And I think it was quite funny between regions to install cluster FS. Like, the first time I installed it, like I was trying it and it was very slow, like why? And then I started thinking and I was like, yeah, of course, because every IO just goes from US to France, so the Atlantic is bigger than I thought.
Yes, it is.
So then basically I took a second node in the US for like the first replications that are just inside the same data center, and then you have another type of replication for cluster, so you can still replicate the data in France, but it doesn't wait for the acknowledge.
So it's more of an asynchronous or an immediate acknowledgement.
But that was funny, like just to do the benchmark and see, because basically you don't see it where, like the first time I tried was on Big 5. On the Big 5 you don't see much of the latency, of course, because there's just one command, so then it's pretty fast, so the override is very slow between those two locations. But as soon as you start, like I was doing like git pull, like what some people do, like to install a new website or stuff like that, and it was taking forever. And
Once you actually transferred over some real distance.
yeah, that was exactly that, like too many files, so of course. So it was a pretty funny one.
Especially for small block I/O,
Yeah.
that's it's basically latency at a first byte. And if you add the entire ocean between you and your first byte, that's a lot of latency.
Yeah.
Well, you didn't get 6, it looks like. You only got
I did only 5, yeah.
3 workers, it looks like.
There's only 3 survive. No, we'll do a quick check.
It's got demo 5, but it says worker 1, 2, 3.
I may have thinned it up a little after I realized how long this was taking me on the car ride over. So it's a total of 6. That's my bad for not adjusting the script. So that's on me.
Basically the same thing you did before.
Yeah, I'm going to run a different
Okay.
a different service example. Let's see if I have my different service example. I do. I am going to pull it from here. So this is one of Docker's demos they do at their conferences. I'd steal their image because I'm not much of a developer, or at least I don't have time to be much of a developer, I suppose. Yeah. This hexadecimal number. Let's get a timestamp. Oh.
It's been a long day, Josh.
It has. I drove in from LA, so I am a little
frazzle you right there.
Yeah. Thankfully, somebody was sitting in the car doing most of the driving, so I got to sit there and work on this while trying not to suffer motion sickness. So what I'm doing is creating a service called demo-jb. I've got one instance of it rolling to begin with. It's being published to port 80. And basically, it's just a website that publishes a random city name. So it's like kind of recommending a city to you. So again, using the power of the mesh network, we're just going to hit a random IP. This time I don't have to worry about a port 80. And you can see now I have the container name. So message from. Now let's zoom that in. So there we go. Message from that container suggests that you visit wherever the heck that is, some randomly generated name. So now we will start scaling that up, but I'm going to run this in a couple panes of glass. So here, I'm going to do one minor adjustment to my script. We're going to hit two different servers. So this is just a simple do while. It's going to curl the two websites that I've popped in here and ask for the city, essentially, right? So over on this side, let's call my, So there you go. I'm asking two separate servers for recommendations. And you'll notice that right now I am hitting all the same node, or all the same container, regardless of the node I'm on, right? I'm now going to ask the service to scale up. So back to my notes. We're going to scale this to 10 containers, servicing my request. So here we go. Control V. Make sure I hit it. Yeah. So now, eventually, as these things start to download to other nodes and actually do that scaling up, you'll see that the container IDs will begin to vary.
They should come up pretty fast because that demo JB is in the local cache now, right?
It's in the local cache of one node.
I see.
I want to see if I actually hit the return button. Ah. Yeah.
Oh, you gotta throw it at the manager.
Yeah, that's my bad. It's like it's not doing its thing. There. Scale one or multiple. Oh, yes, there. That's the one I want to scale. All right. So there's a ping fail as different things start to route and come online. And now you'll notice the containers are starting to randomize a little bit more, and we're still getting randomized IDs. Now, I could have done a rolling update. I didn't specify a particular image. The nice thing about this image, if you ever want to build your own demo, is there's a version 1.0 and a version 1.1. I just drew on latest for tonight's demo because it's nice and easy, but I just wanted to show, right? So I now have this pinging across 10 containers. So we'll take a look at that. Docker service, PS, JB. You can see where all my 10 containers are running. They're spread across the workers and the managers and how long they've been up and running. So that's a little nicer one, and of course when you're ready to kill it all off, you just remove the container, service. Eventually, these will bleed out, and I'll just get refusals to answer me back.
Can we use affinity? Like
You can.
station ID or something?
If you start actually setting up all the labels, so I have to customize the config files a little bit more so that the engine's already unique labeling. But yeah, you could actually create affinities or anti-affinities. You can also create affinities between containers, saying I need these two containers co-located at least on the same node for whatever reason. And I have stopped getting anything because there's nothing left to hit. All my requests are dying.
So why the errors? Well, where the traffic start getting forwarded to upstream before they pass it for southbound?
Yeah, basically they started going through that the mesh network. It took a little while for the gossip network to start updating the loss of these different containers. And in the forward going, it initiated a container, but the container hadn't brought the service fully up, so that's why you got a couple errors up front. So with everything, you know, it's an imperfect system, but far easier than it used to be, that's for sure. I will show you the last command with Docker Machine that everybody who's ever used Docker should have already kind of got, which is this: Docker Machine RM in the true Docker Machine style. Yes, I'm absolutely sure. And that is the other quick way to clean up all your nodes and destroy your demo.
That
So,
was faster. It's not graceful.
not graceful. I didn't care what was running. I just killed them all. Well, I hope that gives you a brief kind of overview of where Docker's come in a year. I think Docker's declared it themselves that this is the year of ops, and that they are focusing on making this a more ops-friendly product. Obviously, there are a lot of people who have issue with where that should be and what levels of ops should be out there. So, you know, it's going to be hopefully that competition will, you know, invigorate creativity and, you know, help things kind of accelerate faster. I will say it's always interesting every 2 months. So I teach this course on a semi-regular basis of training actual people in regular classes who are learning this, and the material is always 3 months behind whatever version I'm sitting on. So it's still evolving fast, and hopefully you guys continue to find interesting ways to implement it in the real world. I mean, the next time I do one of these, I'm hoping I get, you know, half the room in production somewhere. Thank you so much.
Thanks,